Hola clase. Today we are going to learn to rationalize denominators. We're going to do it for both real numbers and complex numbers. As usual, I could give you a step-by-step guide on how to do it, and then we will make actually 2 examples together this time. Now remember that the objective of rationalizing denominators is to eliminate surds of the denominator. Leave that denominator as a rational number. That's why you call it rationalize. And for that, there are a couple of things that I need to know. First of all, I need to know that I, the complex or imaginary number, it's the square root of -1. So it's actually a surd, not that we see it as it. And then I need to know the concept of a conjugate that is similar but slightly different. In the real numbers, if I've got a number that has a surd part, the conjugate of it, it's the same number but with the sign opposed. And in complex, if I've got a complex number, it's the conjugate following the same idea. It's the negative of the surd, so it's going to be the negative of the imaginary part. And one thing that comes useful too is the difference of squares, which you do by expanding if you don't remember it. But if I've got a plus b times a minus b, that it's the difference of both squares, and I don't have to expand by hand. Now on the how to, step by step. First of all, you're going to conjugate the denominator, whether if it's a real number or an imaginary one. Once you have it, you're going to multiply both the numerator and denominator by that number, which is the same as multiplying by 1, but in a way that actually helps you. After you do that, then you just need to simplify. Now let's see that in an example, first with real numbers. And they ask us to rationalize this. 5 over 1 plus 3 over a. Now I need to look at the denominator. It doesn't matter what I see in the numerator. Now the conjugate of that is keep everything the same, and then instead of a plus, you put a minus in there. That means that this fraction here that has an irrational denominator is going to be the same as multiplying both top and bottom by the conjugate. And remember, I can do this, there's no problem, because this is to all effects 1. So I'm not changing anything in there. Now I just need to expand and simplify. On the bottom, I know this is a difference of squares, so square of the first, 1 square is 1, minus square of the second, 9a. On the top, I expand that bracket, 5 times 1, 5, minus 5 times 3 square root of a, 15 square root of a. I have a quick look, there are no like terms anywhere, so I cannot simplify any further. Done. Let's see a second example, in this case with complex numbers. So remember, complex numbers have an imaginary part somewhere. So in this case, we've got this. 4 minus 12i over 3 minus 4i. So now, more of the same. We look at the denominator and conjugate it. This exactly the same. Everything stays the same, and the imaginary part changing sign. So that means that this fraction of complex numbers that I've got in here is going to be the same as multiplying both top and bottom by the conjugate. Let's make this fraction line actually reaching there. And from here, it's a matter of expanding and then simplifying. All right, let's do the denominator first because it's easier. Now, remember that you're going to have an I square here, and that's going to be a minus 1. So let's do it all in steps. Square of the first, 3 squared, it's a 9, minus square of the second, it's going to be a 16 times minus 1, so the sign changes. Now in the numerator, we don't have this difference of square to make things easier, but we can go and do it step by step. 4 times 3, it's a 12. 4 times 4i, it's going to be a plus 16i. Minus 12i times 3, it's going to be a minus 36i. And then using the same idea, remember in here, we're going to have a minus 12 times 4, which is going to be a minus 48, but then times I squared, it's going to change the sign in there. Now you actually have like terms because you've got some real numbers there, real parts of the complex number, and some imaginary parts in here, imaginary parts of the complex number. So you can simplify by combining like terms. I'm just going to simplify the denominator as well, and then the real part, 12 plus 48, 60. The imaginary part, 16 minus 36 minus 20i. And this is a number with an imaginary and a real part. So if we simplify, remember, this is going to be the real part. This is going to be the imaginary part. 60 over 25, that's the same as 12 fifths, minus 20 over 25, which is 4 fifths of 5. We cannot simplify any further, so we're done. Double bar it, and we're done. Okay, now it's your turn to go and practice. Thanks for watching.